Over 2,500 years ago, a Greek mathematician called Pythagoras claimed that in a right-angled triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. In other words, the area of the square on the longest side, the hypotenuse, equals the area of the square on the shortest side, plus the area of the square on the middle side. So for every right-angled triangle, a squared equals b squared plus c squared. To work out the length of w for this right-angled triangle, we use the following equation. W squared equals u squared plus v squared. For this example, in order to find e, we use the equation e squared equals c squared plus d squared. In this example, the length between the points P and R, PR, can be solved with the equation PR squared equals PQ squared plus QR squared. In this example, we are looking to find the length of x. We can achieve this with the following equation. X squared equals y squared plus z squared. Here we're looking to find the length AC. We can do this with the equation AC squared equals AB squared plus BC squared. In order to find the hypotenuse of the above triangle, A squared equals 6 squared plus 8 squared. A squared equals 36 plus 64. A squared equals 100. A equals square root of 100. A equals 10. 5 squared equals 3 squared plus c squared. 25 equals 9 plus c squared. C squared equals 25 minus 9. C squared equals 16. C equals the square root of 16. C equals 4. Trigonometry is used to calculate lengths and angles in triangles. The type of trigonometry you are going to use here only works in right-angled triangles. The longest side opposite the right angle is called the hypotenuse. The side opposite the angle we are using is called the opposite. The side next to the angle we are using is called the adjacent. The sine ratio is the opposite over the hypotenuse. Therefore, sine theta equals the opposite over the hypotenuse. The cosine ratio is the adjacent over the hypotenuse. Therefore, cosine theta equals the adjacent over the hypotenuse. The tangent ratio is the opposite over the adjacent. Therefore, tan theta equals the opposite over the adjacent. Most people use the word SOHCAHTOA to remember these. An 8-metre ladder rests against a vertical wall, making an angle of 60 degrees with the ground. We know the value of h is 8 metres, and we want to find a, the distance the feet are from the wall. We know the angle is 60 degrees. Cos theta is equal to adjacent over hypotenuse, or a over h for short. Cos 60 degrees is equal to a over h. Cos 60 degrees is equal to a over 8 in the diagram. A is then equal to cos 60 degrees times 8. A is 4 metres. A boat is 100 metres from the base of a cliff. The angle that someone on the boat would look up to see the cliff top is 42 degrees. We know the value of A is 100 metres, and we want to find O, the height of the cliff. We know the angle is 42 degrees. Tan theta equals O over A. Tan 42 degrees is equal to O over A. Tan 42 degrees is equal to O in the diagram over 100. O is equal to tan 42 degrees times 100. O is equal to 90 metres. A children's slide is 8 metres high, and it makes an angle of 30 degrees with the ground. How long is the slide from the top to the ground? We know the value of O is 8 metres, and we want to find h, the length of the slide. We know the angle is 30 degrees. Sin theta equals O over h. Sin 30 degrees is equal to O over h. Sine 30 degrees is equal to 8 over x. X times sine 30 degrees equals 8. X equals 8 over sine 30 degrees. X equals 16 meters. A ladder of 8 meters leans against a wall. Its feet are 2 meters away from the base of the wall. Work out the angle between the ladder and the floor. We know the value of h is 8 meters and a is 2 meters. We want to find the angle between h and a. Cos theta equals a over h. Cos theta is equal to 2 over 8. Theta equals inverse cos of 2 over 8. Theta equals 75.5 degrees. A large children's slide is 30 meters long and is 10 meters high. What is the angle between the slide and the ground? We know the value of O is 10 meters and we know the value for h is 30 meters. We want to find the angle opposite O. Sine theta equals O over h. Sine theta is equal to 10 over 30. Theta is equal to inverse sine of 10 over 30. Theta is equal to 19.5 degrees. A boat is 50 meters from the base of a cliff, and the height of the cliff from the sea level is 90 meters. What is the size of the angle that someone from the boat must look up to see the top of the cliff? We know the value of O is 90 meters, and we know the value for A is 50 meters. We want to find the angle opposite O. Tan theta is equal to O over A. Tan theta is equal to 90 over 50. Theta equals inverse tan of 90 over 50. Theta equals 60.9 degrees. Angles of elevation are measured upwards from the horizontal. Angles of depression are measured downwards from the horizontal. Bearings enable us to work out the direction of one object or place from another in more detail than using north, south, east and west. We use angles measured in degrees and references to north, south, east and west. Remember that the measurement always starts from the north or the south. For example, north 60 degrees east and south 60 degrees west. We can also use three-figure bearings which are always measured clockwise from the north. For example, 210 degrees.